We need to simplify the given expression. So what we'll do first, we'll try to combine cosine theta minus cosine phi followed by sine theta minus sine phi by using the formula that cosine theta minus cosine phi, that this is given by -2 times sine of theta plus phi over 2 multiplied to sine of theta minus phi over 2, and sine theta minus sine phi, so this is given by 2 times cosine of theta plus phi over 2 times sine of theta minus phi over 2. So let's work with the first term only, but we'll work with the first term, the term inside the parentheses. That means cosine of theta minus cosine of phi iota times sine theta minus sine phi. So this will be equals to, we have -2 times sine of theta plus phi over 2 times sine of theta minus phi over 2 plus, so here the second term will becomes 2 iota times cosine of theta plus phi over 2 times sine of theta minus phi over 2. Now from the first term and the second term, we can take 2 times sine of theta minus phi over 2 as the common factor. So this will get multiplied to negative of sine theta plus phi over 2 plus iota times cosine of theta plus phi over 2. Now our next goal will be to convert the real part, which is a sine function, to a cosine function, and the imaginary part from cosine to sine. Now here we will be using the fact that sine of pi over 2 plus theta, so that's equals to cosine theta, and cosine of pi over 2 plus theta, so that's equals to negative sine theta. Using this particular idea, we can rewrite our expression as 2 times sine of theta minus phi over 2 multiplied to, so here we have negative sine theta plus phi over 2, so we'll use this particular fact and rewrite it as cosine of pi over 2 plus, our theta is actually theta plus phi over 2, and the second term iota times cosine of theta plus phi over 2, that's simply equals to sine of pi over 2 plus theta, so our theta here is actually theta plus phi over 2. Fine. Now in the next task, what we'll do, we'll raise both sides to the power of n. So we have cosine of theta minus cosine of phi plus iota times sine of theta minus sine of phi, whole raised to the power of n, such that we get 2 raised to the power of n times sine raised to the power of n of theta minus phi over 2. And here we have cosine pi over 2, let's write it down, cosine of pi plus theta plus phi over 2 plus iota times sine of pi over pi plus theta plus phi over 2, whole raised to the power of n. Now when we apply the De Moivre's theorem simply states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of n, that this is equals to cosine of n theta plus iota times sine of n theta. So let's apply De Moivre's theorem. This is going to give us 2 raised to the power of n times sine raised to the power of n of theta minus phi over 2 whole multiplied to cosine of n pi plus n theta plus n phi divided by 2 plus iota times sine of n pi plus n theta plus n phi divided by 2. Right. So we have obtained one of the term. Now we'll move on to the next term. So the calculation will remain exactly the same. So here we will have cosine of theta minus cosine of phi. So this time we have a negative iota multiplied to sine theta minus sine phi whole raised to the power of n. So this will become equals to 2 raised to the power of n times sine raised to the power of n of theta minus phi over 2, whole multiplied to cosine of n pi plus n theta plus n phi divided by 2. Now the only difference here, we'll have negative iota here times sine of n pi plus n theta plus n phi whole divided by 2. Now our goal will be to add these two expressions. So let's add them. So this will be equals to, I'm only considering the expression of the right hand side. So in both the two expression, we have this term which is exactly the same. So we can take it as a common factor, 2 raised to the power of n multiplied to sine raised to the power of n of theta minus phi divided by 2. Now when we add this expression with this expression, the imaginary part cancels out because they are additive inverses of each other. So we'll only have the real part, but that will be 2 times the real part, which is cosine of n pi plus n theta plus n phi whole divided by 2. And 2 raised to the power of n and 2, this will get multiplied to give us 2 raised to the power of n plus 1. So therefore finally let's write down everything. So we have cosine of theta minus cosine of phi. This is added to iota times sine theta minus sine phi whole raised to the power of n, added to cosine of theta minus cosine of phi minus iota times sine theta minus sine phi whole thing raised to the power of n. So this came out to be equals to 2 raised to the power. So we are going to add these, multiply these two. So we have 2 raised to the power of n plus 1 multiplied to sine of theta minus phi divided by 2 times cosine of n pi plus n theta plus n phi divided by 2. So this is the simplified form.